Today's video is going to be about Christmas lights, which is a little bit of a weird video for a sort of technical, smart home, networking type YouTube channel. But in this video, we're going to do something a bit interesting. We're going to take a look at these smart Christmas lights and talk about how we can hack them to control them without using the manufacturer's provided app, and instead control them from Home Assistant and over an API from a Python library. But like most of my videos, this one starts off with a bit of a story, so feel free to skip ahead if you don't care about that. But I was out shopping for Christmas decorations, you know, the sort of thing you do at this time of year, and I was going through looking at all the usual stuff, and it came to then buying lights. And I was standing in the aisle looking at all the Christmas lights, and got thinking that realistically with modern technology, surely Christmas lights should be able to be better than they actually are. Because in a standard retail store, you know, where I was, I think it was like a garden centre or something, all they really had were either white lights or coloured lights. And when I say coloured lights, I'm just talking about a string of LED lights where each light is a different colour. You know, they're not colour changing or anything, it's just a bunch of different colourful LEDs. And then you've got the option of either static ones or ones that have some sort of patterns and flashing sequences that are just controlled by a little controller plugged in line on the cable. And half the time with those lights, they don't have any kind of memory chip, so when you plug them in, they turn on some stupid in-store demo mode that cycles through all the different patterns, and every 5 minutes turns into some ridiculous flashing rave pattern that's ridiculous. And then you end up crawling down under the tree to find the little controller and press a button 5 times or whatever to put it on a better mode. They're just a pain. And I was thinking, surely nowadays, with the amount of smart LED technology and stuff, you can get smart Christmas tree lights. So I started digging around. This was literally while I'm walking around the shop on my phone trying to research all these things. And I looked around, and yes, you can kind of find some, but a lot of them, or in fact most of them, are those sort of Tuya Smart Life things where they rely on a cloud connection, they connect out to a server hosted by Tuya, your then app then connects to that, and I don't really want that. If you haven't seen my channel before, I do a lot of smart home stuff, but my main focus is things that are locally controlled, so they don't rely on cloud connections, they don't rely on remote servers, they can all run locally on my local network, so my server at home can talk to my Christmas lights directly over my local network without relying on any cloud services. It's a lot more secure, a lot more reliable, and it means that I don't have the issue where like a company can say shut down the servers and the product I've bought is useless. Doing it this way means that as long as I have the local network set up and all the devices still work, I can control my product and I'm not reliant on the manufacturer after buying the product. So those Tuya ones wouldn't really work. There were a few other options. Nanoleaf do some that are Matter compatible that may have worked, but they were very expensive at like 120 odd pounds. Philips Hue do some that would be great, but they're 200 pounds. Didn't want to spend that much. And while of course I could have made something myself, you know, go out and buy a string of individually addressable fairy light kind of things and connect it up to some sort of ESP based controller and flash custom firmware on it. I wanted to get the Christmas tree up this weekend. In fact, I literally want to get this video sort of sorted now so I can get the Christmas tree up. I didn't want to be sitting trying to figure this out because I left it quite late. And likewise, those strings of addressable LEDs generally don't look that nice. They're usually quite bulky LEDs with a multicoloured cable. They don't really look that good to have in a Christmas tree. But then I came across these, which are from a brand called Twinkly, and they're the Twinkly strings LEDs. This is a 250 LED version, and this is the multicolour version. They do a few different ones. They do multicolour plus white, which is RGBW, and then they also do a bicolour version. This was just the cheapest option, multicoloured, and it's about £60 or £66, I think these were in Argos. And that was the other thing. Because I want to get the Christmas tree up today, I wanted something that I could literally pick up in a store today, not have to try and order something from online and wait for it to turn up. And in my research on these, literally on my phone while walking through the shop, I noticed that these have a Home Assistant integration that mentions that it uses local polling. And that's a very good sign, because that means that it shouldn't require a cloud connection, it doesn't require any remote servers. I can just install that Home Assistant integration, which can then talk directly to the lights over my local network, which is ideal. That's exactly what I wanted. So then while I was still in the shop, the final thing I thought I would do is a bit of due diligence and install the app just to check it out. So I installed the Twinkly app on my phone, opened it up and saw the beautiful login screen. Yep, this still requires a login. So even though these have full local control over the local network, the app requires you to set up an account and log in. And this just drives me mad, because this kind of thing is unnecessary. Sure, if you want to control these remotely over the internet, fair enough, and accounts may be sensible. But if all I want to do is set these up and locally control them over the network, this is silly. I shouldn't need a login. Because if it didn't need a login, I could keep a copy of the app safe somewhere, keep the APK file somewhere, and even if Twinkly went completely out of business, the app disappears, whatever happens, I could continue to use my lights. However, because the app now requires a login, I can't, because this will now talk to servers at Twinkly to do the login. If Twinkly went out of business or stopped supporting this app, I wouldn't be able to log into the app. And while these do have local control, officially you need to use the app to connect them to Wi-Fi. So obviously if I set them up and connect them to Wi-Fi and they then work for the duration, but then if I ever needed to change the Wi-Fi settings, move to a new Wi-Fi network, something like that, or the lights got accidentally reset, if it got to a point that the app no longer worked or I couldn't log into it, then I wouldn't be able to use the lights that I've bought. So at that point, I wasn't really going to buy them because I thought, that's just annoying. I'd have to rely on the app to log into. That's just really silly. And I still say, that's really silly. But then I was still walking around the shop researching these Christmas lights, as you do, rather than looking at actual Christmas decorations. And I found out that these have actually been quite extensively hacked. People have gone in, done a fair bit of research on these, and reverse engineered the network communication protocol. So not only is there a Home Assistant integration, there's also a couple of different Python libraries. In particular, there's one called XLED that provides a completely fully featured interface to these lights. And in particular, that library also supports connecting these to a Wi-Fi network. So if I use that library, I can not have a login on the app and actually still connect to these. They broadcast a basic local access point you can connect to initially. And I should then be able to use that Python library and API to connect these to my Wi-Fi network without relying on the app and therefore without needing a login. So that's what we're going to try and do in this video. We're going to try and set these up, try and connect these to Wi-Fi with the Python library without using the app, and then actually try and see how we can configure these, see what stuff I can do with Home Assistant. There's a couple of other libraries out there for doing various animations on these and doing all that kind of stuff, so we'll try that out and see what I can make these do without relying on the app. Now, of course, that's not saying the app is bad. The app actually does look quite good. It does quite a lot of advanced stuff. For example, you can put the lights on a tree, use the app to then take pictures and videos of that tree where it kind of maps out where the lights are, and you can do like full-on graphics. So you could say have it displaying the flag of a country or a picture on your tree because it's mapped out where the LEDs are. So the app actually does look quite cool, and I'm not dismissing that at all. But this is almost a point of principle that I do not want to have a login and a user account for my Christmas lights that I use once a year. So this is almost a point of principle. I want to try and set these up and see how much I can make these do without touching the manufacturer's app. So let's see how this is going to go. So first of all, we'll take a look at the lights themselves, get them out of the box, take a quick look at the hardware. Then what I'll do is I'll get the laptop out, try and get these connected to Wi-Fi, hopefully it works. Otherwise it's a bit of a pointless project. And then what we'll do is I'll go away, get them on the tree, and then while the tree's up, I'll sit and fiddle about with them, try and see what I can make them do, and then I'll come back towards the end of the video and talk about some of the things I've found. I might also try the app out, we'll see, but it'll be interesting to see how much I can make these do. So if we open these up, as you can see, yep, Twinkly strings, there's a manual, some stickers, so you can put a sticker on something and advertise the particular type of Christmas lights you use, fair enough. I think these actually came from a Kickstarter a few years ago, and they actually do a lot of other products, it's worth mentioning. This is just their sort of strings, so just their sort of standard fairy lights, but they do things like big curtains you could kind of have up that you could do quite a lot of 2D graphics over. I think they do kind of icicle lights, they do quite a lot of other types of lights, so it's definitely worth checking out if you want kind of nicely made RGB controllable lights, because as you can see, these are a lot nicer than trying to do some sort of DIY project. You get quite a nice, normal, decent form factor. You then get a little card here in the box, of course you do. See what that says. We're glad you chose to bring Twinkly into your life. Never thought I was bringing something into my life buying Christmas lights, but fair enough. And here we have the lights. So they basically look like a fairly standard set of Christmas lights, which is exactly what I wanted. I didn't want some sort of bodgy controller and weird connectors. I just wanted something that just works, that I can just quickly put on a tree every year. So you get a plug, your standard sort of 2-pin thing you connect with Christmas lights. You get your controller here, and then you get your lights. Now, interestingly with these are a 20-meter chain, so there's 20 meters of lights here, but they both, or it's like you get two 10-meter strings that wire back to the controller. I've not seen that before. I presume it's some sort of either current limiting thing or like maybe a message integrity thing, because there's also going to be some sort of data signal going through these. Maybe the data signal can only traverse 10 meters of lights reliably, not 20 meters, so maybe they kind of split them like that for that reason. I don't really know. Be interesting to kind of find out, but yeah, not sure why they've done it like this. So it'll be something I'll need to think of when I'm putting it on the tree, because I can't just wire it kind of end to end. I'll need to kind of think of the fact there's a controller kind of in the middle somewhere. Probably ultimately kind of go sort of, one half up, one half of the tree, one half the other side of the tree, and this underneath. Don't really know, but anyway, that's not the point of this video. I don't really... this is definitely not a Christmas tree decorating video. This is a Christmas lights video, which is completely different. So, yep, there we get the LEDs. So there's two different strings there. Nice to see black cables as well, so these will look quite good on a tree. And this is the sort of thing you get with buying a sort of pre-built product like this, rather than building something custom. All those custom ones end up with either clear cables or like multicolored cables. These look like normal lights, which is a lot better. Get the LEDs on there. Get your two strings. Sort of ferrite core on that. they're definitely concerned about interference. I suspect that's probably why it's been split in two, because yeah, you've got a ferrite core there as well, which is almost certainly to do with the interference of the data signal that will be passing through all these bulbs. Because these will be individually addressable LEDs, so essentially what you have is each LED's kind of like got a shift register in it, and you can kind of send a message to the first LED, and then that passes it to the second LED, and so on. And you can use that to kind of pass messages and address any LED. So with this set, any LED on the chain can be set to any color independently. So you've essentially got full individual pixel control of these, which is quite cool. Then we have this little controller, and that's all you get. So yeah, you just get the two strings, your controller there, which has a button on it, presumably for pairing and things like that. And this cable here goes to a power brick. And also looking at the box, these are IP44. So yeah, I think you could use those outdoors. Those would be suitable for outdoor use, I think. Not sure what the standards are for Christmas lights, but yeah, these would be, they're outdoor suitable there. So you could use these outdoors as well. So that's pretty good too. So yeah, that's hardware there. What we'll do now is we'll get them powered up and try and get them to connect to Wi-Fi, just to check if this project is even feasible. I'll then go away, get these on the tree, and see what I can make them do. So first of all, let's get the laptop out and see if we can connect these to Wi-Fi. Okay, so now let's turn them on and see what happens. So in theory, if we turn these on, they should light up and then start broadcasting at an access point. So turn that on there. Cool, so as you can see, the lights now lit up. So then I lit up and doing sort of rainbow pattern, that makes sense. And if you look at the controller here, it's flashing a green LED. And from the reading I've done, that means that it's broadcasting a Wi-Fi access point. So in theory, I can connect to this access point from the laptop and start talking to this. And this is quite a good design. With this, you can either connect it to your Wi-Fi network, or you can connect directly to the access point that this is broadcasting and still control it from the app. And this makes a lot of sense, because there's definitely going to be situations where you want to configure a system like this. You don't really care about the smart control in the sense of being able to continuously control it, but you maybe want to be able to set up certain patterns or something, but you might not have a wireless network. You know, if you're installing it on a Christmas tree outside in the middle of a garden or something, you might not have an access point that this can connect to. So it is good that it does that. And that also means that I can connect to that access point and hopefully use the Python library to issue a command to this to connect to my main wireless network. And then once it's on my wireless network, I can then integrate it with Home Assistant, all without using the app. So let's take a look at the laptop and see if it's working. Okay, so here I now have a laptop. As we can see, it is broadcasting a wireless network. So we can see there, it's called Twinkly _ EEC515. That'll be kind of an identifier, like a serial number of my one, so it'll probably have a different number on the end. But yep, it's broadcasting a network, and apparently the default password is Twinkly with a capital T 2019, which is presumably, I think it's when the generation 2 of these came out. I think that's 2019. So in theory, we can press this and connect to that network. So let's see if that'll connect. Showing a question mark right now, presumably getting an IP address. Or, I mean, the network also won't have an internet connection, so that might upset my machine. But in theory, we should now be connected to that network and be able to control these. And yep, so taking a look up here, we can see we are now connected to that network. I think the question mark just means there's no internet connection, because obviously this isn't connected to the internet. But yep, we are now connected. And if we take a look here, the flashing LED has now gone solid, which presumably means that the device is connected to the network. So hopefully I can now download that Python API and start talking to these. Okay, so now here we have a laptop, so let's take a look at this. I've also turned the lights off. Turns out pressing this button here cycles through a few different modes, so that's actually quite nice. So even if you're not using the app, or you don't want to use the app, you just want to get them working, you can actually just use this to cycle through a few different modes and at least vaguely use them. So that's something there, but that's them turned off there, it's just because it was playing with messing up the camera exposure. And then here on the laptop, we're now connected to that network, so we're connected to the access point being broadcast from this, and I've installed the library. So the library is called XLED and it's on GitHub, so you can see that's it there. So that's all on GitHub. I'm just going to film the screen. I do apologise, I just can't be bothered setting up screen recording. I need to get these on the Christmas tree ASAP. But that's the library there on GitHub, so I've installed that. It's a Python library. It is also on PyPy, which is Python's package repository, so you can install it through pip. However, it seems as though in a recent firmware update to these Twinkly devices, they've changed the way they connect to Wi-Fi. And this library does contain a method for connecting to the newer version, using the new method, but that doesn't seem to have been updated on PyPy. So if you install it from pip, you'll get the old version and it won't have the function you'll need to connect to a more updated version of the device. So instead what I've done is I've just downloaded the Git repository from here and installed that instead. So I've created a Python virtual environment, downloaded that Git repository, you can see that there, so I've cloned the Git repository to XLED and I've installed that package. So in theory, we can now use this to connect to the device. So as I mentioned, my laptop is connected to the access point being broadcast from the Twinkly LED strip. So if we pull up a Python interpreter, we'll just work with this, like that there. So the first thing we're going to do is import the library. So just import XLED, there we go. And the next thing we want to do is try and discover the device on the network. So because it actually does support also discovery. So we're just going to go device equals xled.discover.discover, like that. And it'll sit for a second, and hopefully we've now found the device. So it's the device there. Yep, that's worked. So as you can see, it's found the device, it's found an IP address. That will just be the device, the IP address because it's its own access point, and the MAC address. So we now have a device here. Now we need to create an instance of the control class. So we'll just go control equals xled.control interface. Oh, if I can spell right. Like that. Now this obviously goes without saying, this does require some level of Python knowledge to be able to do this type of integration. So if you're going into this and you've got no experience of Python, you probably want to find a different option. But if you're familiar with Python, this is relatively simple stuff. So to this, we need to pass the IP address and the MAC address. So device.ip address, device.hw address, like that. And now we have a control object. So now if you look at control and see what functions we get here, as you can see, there's a ton of different options here. So there's firmware update, there's the option to get modes, there's the option to get LED color, set the LED color, get the brightness, set the brightness, all that sort of stuff. So from this, we can actually control this directly from this API. Although to be honest, I'm going to be using Home Assistant for this. What I care about here is connecting this to the network. And this is done here with this network mode. So as you can see, we can first of all say get network mode or get network status. So if we do control.get network status, like that, they always return this object, so you need to do .data to actually see what's inside that object. But as we can see, we're connected to the network, or we're broadcasting SSID, so it's in AP mode. And that makes sense. So we're currently sitting in AP mode. That's what we needed to do. So now, let's connect this to my Wi-Fi network. So we'll just clear the screen just to kind of make it a bit easier. So this should be relatively easy to do. We're going to go control.set network mode station. And this is where there's two options. Set network mode station and station v2. And this is why I had to download it from GitHub rather than using the PyPy version. Because this v2 one is the one we need to use for the newer firmware version that this product that I have has. And that's not on the PyPy version. So station v2. And then all we need to do is pass into this my SSID and my password. Okay, so we have my SSID and password in there. So if we press enter, in theory, this should connect to my network. I said in theory, that didn't work. Okay, so we're getting an error here. Objective type bytes is not JSON serializable. Great. That indicates that the library maybe isn't as reliable as I thought it would be. Okay, so what I'll do is I'll go away off camera and I'll dig into the code and try and figure out what's happening here. And then we'll come back. Hopefully it's an easy fix, but I really hope it's an easy fix, otherwise this video is completely pointless because I'll have to use the app to at least do the initial Wi-Fi connection. But I'll go away off camera and see if I can figure out what's happening. Okay, so I've done a bit of debugging and I think I found the root cause. In one of the files here, it's control.py in the XLED library. We've got the function here, so set network mode station v2. And as we can see, we're setting up this JSON payload. So we're creating a JSON payload here, or an object, and then that ultimately gets JSON encoded. And there we're getting saying that a bytes object wasn't JSON serializable. And what I found is that at this point, by printing this object out, when I try and connect to Wi-Fi running this function, this enc SSID and enc password are actually byte strings, not strings. Now they seem to be base 64 encoded, so it is a base 64 encoded string, but it's stored as bytes still. So I think all I need to do is decode that to an actual string, and we should be good to go. This is because there's some sort of setup here where when you connect to the device, it kind of encrypts the Wi-Fi credentials before it sends them over the network. I don't know why it does this. It's a bit weird because you are still connecting to an encrypted SSID. I presume they've got some reason to do it. But yeah, so this does actually need, there's some logic in this library that encrypts the Wi-Fi password and SSID that you're using, or the key and SSID you're using, before sending them over the API. And that's what's happening here. So these are encrypted SSID and password, and that's what the issue was. So in theory, all I need to do is .decode on the end of these, and that will then decode that byte array to a string, and that should hopefully be able to be JSON serialized. So decode there, just like that, and fingers crossed, that should be enough. So what I'll do is I'll reinstall this library, and I'll try again. Okay, so let's try this again. So I've now got the setup again, reinstall the library with that newer version I've now changed. I should probably submit a pull request. I might do that at some point if I ever get around to it. But that's now working. So what I've now got is basically the exact same thing we were before. Connect to the network, import the library, found the device in the network, all that kind of stuff. Is that the same stuff we did before? But now I've changed the library. So in theory, when I press enter now, it should connect to my network. Okay, so it didn't fail that time. I've got these application response 1000s. So let's see if that's actually now connecting. And if we look down the back here, we can see that looks like it's now connected. So we've now got a blue LED instead of a green LED. So I suspect that is now connected to my local network. And as we can see, looking at my access point settings, we're connected to the network. So yep, that's worked. We're connected and we've got an IP address. That's absolutely brilliant. So what I'll now do is I'll go into my router quickly and set up a DHCP static reservation, because I want to be able to connect to this on a static IP address. It's currently getting a dynamic one. That could change. So I'll set up a static IP address on this just so it always gets the same IP address. Then we'll install the Home Assistant integration and see if it works. Okay, so I've now set up a static DHCP reservation, so that'll now get the same IP address every time it connects to the network, so that should be a lot more reliable. Now let's try out the Home Assistant integration. So here we have Home Assistant. I'll try and sort of vaguely show this. Again, just going low tech and filming a laptop because why not? So what we'll do is we'll add integration. And hopefully, or in theory, there's an integration just called Twinkly. So Twinkly, there we are. And we should put the IP address in. So 10.114.3.34. Submit. And hopefully, yep, there we go. That's found it. Area, living room. I really don't use areas in here, but fair enough. May as well set an area. And that's found the device. Yep, there it is. There's my device there. So if I click on that, that says it's off. Now, what if I turn this on? I'll move this so you can see the lights as well. Try and you can tell this is not a highly professionally polished video. I'm just wanting to get these things on the tree, but you can just see the lights in the back there. So if I turn it on, nope. Oh, there we go. The brightness was turned down. Cool. There we go. Brightness up. Turn off. Okay, so turn on and off doesn't seem to be working, but the brightness works. Okay, fair enough. It just seems to be actually basically 0% brightness is off. Okay, that off is basically off. And then you turn it on by setting the brightness. Okay, cool. So that's basically the off button. And then that lets me turn it on. But yeah, that works. I can control it from Home Assistant. Presumably I can pick different colours here. So that's kind of on a multicoloured pattern. I can pick that there. So that seems to work, which is good. Presumably it's a colour picker, so I can pick different colours. There's pink, there's sort of lilac, there's green. So it is kind of working. Now, the only thing I don't see in here, and this was like I saw in documentation, is about how you can't set like effects and patterns through Home Assistant natively. You can see you can pick all these colours, you can set favourite colours, all that kind of stuff, change the brightness, but that just affects all the LEDs at once. There's also this option here for effect, where you can pick effects. But as you can see, if I click on that, nothing comes up. You can just about see it maybe kind of expands like a slight menu there, but there's no entries in it. So there aren't any effects. Now, looking at the documentation, the official thing you would do here is use the app for Twinkly to go in, add your effects. You can download various patterns from their kind of, not store, but they offer a bunch of patterns in the app. You can see on the box here, they kind of offer a whole selection of different patterns you can use, including ones that have like mapped your tree and do all that kind of stuff. And then when you pick one of those patterns, it uploads it to the device. It's then stored on the device. And once it's stored on there, you can then pick those from this effects menu. So you could trigger, you can't design effects in Home Assistant, but you can trigger them. So this is really good. It does mean that if you did use the app because you're being normal and you are just using the app, I think long term I probably will actually end up using the app for this, but on principle I want to try and get this working as much as possible without that login. If you're using the app, it means you can do all your designing, map your tree with a camera, do all that really cool stuff this device supports, and then you can still trigger those effects from Home Assistant, which will be really good because that's kind of what I want. However, there are a few other options for designing these patterns. In particular, there's a couple of Python libraries. You have XLED, which does the main control, but there's another library called XLED Plus that's designed for patterns. It's got a bunch of functions in there for creating different patterns, designing different patterns. There's a bunch of example patterns, which I'll probably end up sticking with or modifying. And what you can do is you use that library, design those patterns, and what it seems to do is then essentially design the pattern and upload it to the device. Once the patterns are then designed and uploaded to that, you can then trigger them from Home Assistant. So essentially it's the same effect as using the app. You design your patterns in the app or through this Python library, upload it to the LED strip, and then you can trigger those patterns from Home Assistant. So that should be pretty cool. But of course, I'm not going to do that right now because I just need to get these working. So I'm going to go away, get these on the tree, then I'll spend some time playing with them, and then we'll come back and take a look at what I figured out I'm able to do with this. Okay, so here we are in the living room, and I've now got the tree all set up. Don't judge my Christmas tree decoration skills, I'm not great at it, but we have the tree set up and we have the lights on. So as you can see, the lights are all working. They're just sitting on a static colour right now, but they work. And I've also set this up in Home Assistant, so I've integrated it with my Home Assistant dashboards that are displayed on my in-wall touchscreens. So as we can see here, we have one of my ML touchscreens. I've made videos about these previously. This is the main control for the lighting, but I can now press main menu, press Christmas tree, and this gives me the Christmas tree control. So this is actually a widget from Home Assistant. This is, I think, the light entity card or something like that. And this is all automatically created, and it lets me change the brightness of the tree. So I can do that and adjust the brightness, just like that. It allows me to turn the tree on and off, so I can manually turn the tree on and off there. And I can also change the colour. So I've got this colour wheel here. I can simply pick different colours and change the colour of the tree like that. And that works really well. I've also integrated this into my normal lighting control. So if I go out to the main menu and into lighting and then turn, say, the room lights off, the room will turn off, the tree will stay on for a few more seconds and then turn off. That delay is intentional just because I think it looks quite nice. If I turn the room lights on, tree will turn on, and the room turns on. So that works really well. Likewise, brightness control. So if I say dim the room down, press that, tree will also dim down. And if I dim the room up, the tree will turn up. And that's actually something I didn't really think would be particularly useful, but it actually works super well. Late at night, I quite like to sit in the living room with the lights really dim just to kind of relax. And normally the tree is far too bright for that. Whereas with this, if I turn the room brightness down, the tree also dims down, so it's actually a perfectly fine brightness. It actually is really nice to have a dimmable Christmas tree. So as you can see, out of the box, I can change the brightness, set all different colours on the tree, and turn the tree on and off. And it works really well. But what about effects? Making it twinkle or flash or do rainbow colours, all that sort of stuff. As you can see down here, I have a drop down that says effect, and I have a bunch of different effects in here. But the tricky thing is, these aren't set up out of the box. These effects are stored on the light string itself. There's obviously memory on that, and you can upload patterns to that, it saves them, and then you can recall them. But out of the box, the string doesn't contain any effects. So all you can do out of the box, if you're not using the app, is change the colour and brightness. The way you're meant to use this is install the app, design your effects on the app, upload the effects to the tree, and then you can pick the effects from this drop-down. But as I mentioned, the whole plan behind this video is to not use that app. So how did I get these effects? Well, to do this, I used a library called XLED Plus. We've already seen the XLED library, which is a Python library to allow you to control the LED string and set it up and do all the Wi-Fi configuration, change the colour, that kind of stuff. And that allows the actual integration with the lights itself. XLED Plus is a companion library to that uses XLED to communicate with the LED strip, but allows you to design and define effects. These are all written as Python functions, so it's a little bit weird, but basically you can write a Python function that kind of creates a set of frames, and each frame is a configuration of lights on the tree. So you have a bunch of different frames, and each frame would indicate what the lights are like. So you have different frames that are, for example, fading lights in and out, or patterns up the tree, all that kind of stuff. As I mentioned, those are written as Python functions, so it's a little bit weird to do, but there's a huge library of samples included with the GitHub repo for the XLED Plus library. There's not much documentation for the library, unfortunately. It's one of those libraries that you basically have to read the code to figure out how it works. But using those samples and then going through the code that was fairly well commented, I was able to figure out how these functions worked and design some of my own effects. So essentially what I did is I cloned that repo, took some of the samples, modified them a little bit, and uploaded them to the tree. Now, I'm not going to go into too much detail in the code. You'll be seeing some screenshots of little bits here and there, but realistically, all the samples are on there. The changes I've made aren't particularly drastic, and this is the sort of thing that if you're not familiar with Python, don't even consider trying it. It's really not a plug and play thing. You really would have to kind of have detailed understanding of Python to be able to write these functions, potentially make changes to the library to suit how you need it to work. I had to make quite a few little tweaks here and there. So if you're familiar with Python, this is definitely quite a fun project, and it was quite interesting to play about with, programming a Christmas tree in Python. But if you just want Christmas lights to work, you're better using the app. Maybe use the local API for the Home Assistant integration, that works really well. But designing the effects using the XLED Plus does require quite in-depth Python knowledge. But with that, I wrote some functions, designed a few patterns, and they've all been uploaded to the LED strip. So now let's take a look at them. So this is just a very quick demo of some of the patterns I've come up with. So we can look at effects here. Here we've got a list of all the ones I've made. So first one is just warm twinkle. So that kind of just twinkles the lights on and off in a warm white colour. Then there's cool twinkle, which is the exact same thing. It's just in a cool white colour. And it's actually really nice being able to adjust the colour temperature of a Christmas tree. Next up we've got crystal, this is basically lifted from one of the samples. I've not really changed this at all. And crystal just kind of keeps all the lights on solid and just twinkles some of them, turns some of them on and off, and it looks quite nice. Blue and pink is just kind of a twinkling blue and pink. Green and red is a twinkling green and red. These are basically, again, samples that I've just lifted. I didn't really change these at all. Candy cane is kind of white and red. Again, this is a sample I lifted. Fire, again, this was just a sample. It's kind of a nice red and orange glow. It's quite nice for sort of late at night if you're in a dark room. Bicolor flash. This one cycles between two different colours. There's always two different colours on the tree, and they flash on white and then fade out to a colour. So it's turned on white and then fade out to a colour, and it cycles through a bunch of different colours over time. Colour flash is the same thing, but it kind of randomises the colours, so you've always got a whole mix of colours on the tree. These are quite nice. They're a bit more subtle than a completely colourful tree. Spectrum is just a sort of complete rainbow one, so that's just all different colours, and they all sort of cycle up the tree. I think that's them all. And that works really, really nicely. And what I really like about this is because the LEDs are individually addressable, it's not like a sort of repeating pattern. For example, here the tree is very colourful, but it's not like your traditional colourful Christmas lights where where you have maybe red, green, blue, and they're all kind of in a pattern. With this, the colours are actually moving up the tree, so it's a lot more interesting to look at. This also applies to twinkling patterns. On a normal Christmas tree where you've, say, got a standard set of twinkling lights, essentially what you actually have is a set of lights with two different channels, and each LED is a different channel from its neighbour. So if it's twinkling, if you look briefly at it, it does look like the tree's twinkling. Actually what you've got is each pair of LEDs is just turning on and off alternately, or something like that. And if you look at it for a while, you'll have seen this if you've ever looked at Christmas lights, you'll look at it for a while and you'll very quickly notice a pattern in the twinkling. You'll kind of see two LEDs alternating, and it kind of spoils the effect. Whereas with this, it's actually a truly random twinkle. So the LEDs are truly randomly turning on and off. Now, in actual fact, it's not randomly calculating it on the fly. It's just basically playing a pre-recorded pattern. So this will eventually loop. But it means that the delays between each LED is slightly more random, and they're actually randomly twinkling on and off, which looks so much nicer. It's a lot more subtle. Plus, personally, I'm not a huge fan of super bright, flashy Christmas lights that do all sorts of patterns. I much prefer a really subtle pattern like this. So with this system, I'm able to actually slow that twinkle right down to a really low speed, so it's nice and subtle in the corner and not distracting like a lot of Christmas lights are. Now, of course, with the app, you can get a ton more functionality. For example, it has a feature I think I mentioned earlier where you can like take pictures of the tree, it maps out where the lights are, and then rather than just sort of randomly twinkling the lights on and off, you could actually position patterns. So rather than having candy cane just be random white and red LEDs all over the tree, you could actually have a spiral of lights going up the tree. But I don't really care about that. That's a bit too garish for me anyway. So this actually works really, really nicely. So there you go. That's a look at my new Christmas lights and how I've been able to set them up without using the companion app and setting up a user account, and instead using the XLED Python library. And it works pretty well. Now, of course, if you just want to use Christmas lights, just use the app. It's a lot easier. But this is kind of like a point of principle for me. I hate when devices require user accounts completely unnecessarily, and this is a perfect example of that. And being able to completely set this up, integrate it with Home Assistant, upload patterns to it, and completely use this without ever setting up a user account is quite satisfying. So yeah, hopefully you found this interesting or potentially useful if you're planning on doing something like this. But all that's left to say now is thank you very much for watching.